Hi everyone, thank you for attending to our presentation. Today we'll present to you how at Betclic we set up a data lake to be able to reproduce some sports events and to do some load testing. Before beginning, we are presenting ourselves quickly. So I'm Nicolas Jozwia. I'm at Betclic since 3 years now. I'm at the architecture department and I'm in charge of the component team, which is responsible to develop and maintain some technical libraries for all technical teams. And I'm with my comrade.
Hello everybody, my name is Etienne Puissant. I've been working at Betclic for 3 years, and I've been working on load testing and performance topics.
So a little bit of context. Maybe you know, Betclic is an online gambling application. We are present on mobile phone, Android, iOS, and on a web application. We are present mainly on sports events such as Champions League, Ligue 1 in France, but also in tennis with Roland Garros, Wimbledon, US Open, for basketball, NBA, and some specificities with MMA for the Poland, for example. We are also present on other universe. By universe, I mean casino, poker, and horse racing. And the promise is to pass from one universe to another one. So for example, if you are looking a football match and doing some bet placement, for example, during the halftime, you can go to play some casino games or horse racing if they are available. We are present in several countries, so France, Italy, Poland, Portugal, and more recently, Ivory Coast and Senegal. A precision, we are working on regulated markets, which means that we have some duties and laws to respect. We have some regulators. For example, in France, maybe you heard about it, we have ANG. In Portugal, we have SRIG. And it's very important to respect these laws because we have to protect our players. So as you can imagine, in this kind of application industry, it's very challenging because you have to be very responsive when you want to do a bet placement, we have some answer. For example, if we take a tennis match, during a set, you have to be very responsive. It was very challenging for us to propose a very good application to our player. That's why in that context, we set up some load testing, and now I will let Etienne explain how we did that.
Thank you, Nicolas. So before we explain how we reproduce our production traffic, let me talk about how we used to do load testing at Betclic. So we start by looking at our monitoring tools like AppDynamics. And as you can see here, we got two APIs, very popular APIs for Betclic, which are the login and the wallet. And we're going to look at those curves and try to create a load profile, a load test profile for each of those APIs. As you can see on the logins, we can see a lot of peaks during the game. And we have a big peak at the end of the game. And this is totally normal because at the end of the game, the people want to come to the application to see if they won and maybe place another bet or get their money back. For the wallet, it's a bit different. We will have like a constant amount of calls during the game, but during the halftime and during the end of the game, we will have a big peak. And this kind of behaviors, we will try to capture them and to create what we call a profile, load test profile, injection profile. That's what you see on the top of the screen. So each line you see on this graph is a popular API at Betclic. And for each of these API, we have like injection profile. So it can be a constant user per second. It can be a peak. It can be an increase, all of that stuff. And then we can use Gatling, which is a very cool tool to do load testing and translate this load test graph into a load test. So that's what you see on the bottom. You see the injection of user that looks like the load profile we have. So those kinds of tests, what I will call classical tests, are cool, but something very important in our industry is that every sports event, every game will be different. It might be like a football game. During the football game, everything can happen. A goal can be scored. For basketball, it can be like a foul. For tennis, it can be something else. So every event will be different. Let me try to explain that. So this is a football game with the pre-match, the halftime, and the end of the game. So there are some predictable behavior we have here. At the start of the game, of course, a lot of people will come to bet. They will also deposit money to be able to bet. And also what is we can predict is the end of the game with a big login peak. And some people, they will maybe withdraw their money. That's what we see at the bottom, a big peak of withdrawals, but they will also maybe place another bet. That's why we have a huge peak of bets at the end of the game. But what's happening in between, it's totally different from a game to another. Let me show you. For example, if a player scores a goal during the first half, it might affect the load, the traffic we have on our platform. And we cannot predict that. If Mbappe decides to score a goal, it's good for us, of course, but our platform will be stressed. And some player, they will come to our application, and maybe they will say, okay, Mbappe is on fire today, he will score another goal. So they're going to place another bet, they're going to deposit money, and all of that stuff we cannot really predict before the game. So this is where the idea of trying to reproduce this kind of events comes, and this is what we're going to show you today. First, we need to get information about our traffic, our production traffic, and then we will show you how we can replay those events. So, Nicolas, can you present how we can get the production data?
Yes, thank you, Etienne. So we decided to do some traffic analysis, but before going into detail, I will explain to you what are user sessions for us at Betclic. So we'll begin with the first line. So let's take a player. He will come in the application. He will do a login. And he will look into selections. Just some details here. A selection, for example, is a winner of a match. Another selection will be a goal scorer. So we can have several selections, and we can do a selection combination. That's going to be very difficult for us to reproduce, for example, manually. And after that, he can do some bet placement. We'll continue with the second line. So the same player or another one will log in at the end of the match, and he will look if he lost or won its bets. So here in the example, he won its bets, and at the end he has two choices. The first one is he can withdraw his money. Okay, it's cool. The one, he can take the money and do over bet placement on another match. So as you can see here with the new screen, we can have several paths in implication, several different workflows, which is very difficult to predict, and that's why we were at our limit to reproduce manually load testing. So we had an idea. So here, classically, on our application, like other ones, on our mobile and web application, we have some logs. And we decided to use these logs. So I will begin with the first line. So I will speak about technical logs. So at Betclic, we are using Datadog to ingest, index some logs. We have mainly three big kinds of logs. So first one, we have two IS logs. In fact, we have several .NET and ASP.NET for all the ones on Windows Server. That's why we have lots of 2IS logs, so we'll take them. We have an API gateway based on Kong also, so we will take these logs too. And finally, we have some varnish cache for the front-end side. So we'll take all these raw logs and we'll send them to an S3 bucket on AWS. A precision here also, we can choose some period. For example, we can take the whole match, the information of the whole match, the half time, or just a time frame which is interesting. So for example, we can take logs when there were a penalty, for example. Second line, so by discussing with our data colleagues, we discovered that they were using a BI tool, which is Snowflake. And they are using events in our IT system. So at Betclic, we have an internal event bus to communicate between our different services. And we discovered that they take all these events and play with them in Snowflake. So we decided to use some particular events, some business events, to our use case. So for example, in some events, we'll retrieve some bet placement information with the different type of selection, with the associated amount, etc. So we'll take, with the time frame which is interesting, these events in logs format, and we'll send them to another S3 bucket on AWS. A precision also here. For GDPR consideration, we are working on the behavior of our player, not the identification of our user, so it's very important to take into account. So I will go directly to the results. I will explain a little bit later the detailed process. So at the end of the magic process, we have some result into another S3 bucket, which will contain some feeder files, and these feeder files will be used by Gatling tool. As Etienne explained just earlier, we are using Gatling, and Gatling is able to use these feeder files. So in these feeder files, we will retrieve all the API in the order they were called in our logs, and we will build some scenario simulation automatically to be able to reproduce a match period, for example. Also, we are using some other feeder files. So, for example, we have some load test user dedicated to replay these matches. Because, as I said, we cannot use some user for GDPR consideration. So now, Etienne, could you explain the kind of magic we have behind that process, please?
Yes, so we got an input, which are the logs and the events, and we got an output, which is the feeder file. But in between, as you can imagine, there is a big process coming in to format the data and make it readable by Gatling. So this is a simplified architecture of the process. First thing I want to mention is that we are using step functions. Step function is an AWS service to create ordered process. And in our case, it's very useful because we will need to process different steps one after another. So let me try to explain what's going on here. So on the left, we got our raw data that's coming into S3 bucket. Then, when the data is in the bucket, we're going to trigger a Lambda that will perform a Glue job. So Glue, it's an ETL from AWS. And with the Glue job, we will do two things. First, we're going to clean the data. We're going to remove all the properties that are not necessary in our logs. As Nicolas mentioned, we got logs coming from a lot of different services, and we can only need some properties to create the feeder file. Then we will have a second job, which is the transform job. Here we're going to format the data, do some processes to sort the data, and make them usable by the next process. Once those two jobs are done, we're going to put the data into what we call the processed data bucket. We can also call it a data lake, because this is from there that we're going to use the data to create our feeder files, but we can also do some cool things. We can use Athena, for example, AWS service as well, to do some analysis on the data. We can perform queries to have information on the data we processed, and we can also use QuickSight to create dashboards and share dashboards about the data we just processed to the teams, so that can have information on their APIs. So, but the important thing here is to create a feeder file. So we need one more step. We need to process this data into a custom business process. It is written in .NET, and it will contain like a lot of business action that we cannot do directly in the step function. So it can be, for example, rehydrating old data for new data, rehydrating IDs for APIs, because we are using extract that might be from 1 month ago, 1 week ago, and all the data won't be available at that time, so we need to rehydrate the data. Also, we need to prepare our load test users, because we are using like specific users for this kind of test, and we might want to manage authentication, for example, for those users. So when this process is done, it's going to create a final file, a feeder file that we're going to put in S3 buckets. From there, Gatling can automatically read the data and run a load test according to the file we just created. So, but before running the load test, we need to think of a few things. First, we need to credit our load test users, because there might be some money transfer during the user sessions. We need to credit our users so they have money, they can place bets, and it's kind of important, because if we don't have it, it's not going to work the same way as it was in production. Second thing, we need to decide the range of the test. As we mentioned earlier, we don't have only football or basketball. We also have poker. We also have casino. And with those load tests, there is no limit. We can just take a poker game, for example, or take a casino game. So we need to decide the range of the feeder file and what kind of user sessions we want to get and we want to test. Last thing, we need to adjust the load. The cool thing with Gatling is that we can adjust the number of users we're going to inject during our load test. This means, for example, this short period of time during a football game where there is a goal, we can reproduce the traffic and do it like times 10 or times 50%. And this really helps us to anticipate. If, for example, during the next World Cup, there is a goal from France, we will be able to predict this kind of behavior by using a load test like this and adjust the load so it's bigger, because we're going to have a bigger range of players during the World Cup. So this is how it looks like when we perform a user session load test. So as you can see, the curve is not the same as the classical load test. It's not as sharp in terms of peak, and it's more representative of what's happening in production. So it's very useful to reproduce what were going on during a time range in the production. So let's talk about tools and pros and cons of this kind of load test and give you a bit of feedback on the tools. First thing, the pros. As I already mentioned, we can test everything we want. We just have to select a time range of poker, of a football game, and we can capture all the logs and replay this traffic and adjusting the number of users we want to inject. So very good to anticipate. The second cool thing is with this kind of test, we're going to find new issues, new bottlenecks in our APIs, because the classical load tests, they are just like sending a lot of users to our APIs, but maybe it's not the right behavior that happens during a football game, for example. So we're going to find new issues and we can investigate and anticipate if there is another event of that kind that happens in the future. Last thing, we can replay a whole game if we want. So, as I mentioned, there is the World Cup coming in less than 1 month, I think. We can take the biggest game we had, like for the Champions League, for example, see what's happening when a player scores goals in that situation, and we can replay this event with like 10 times more users and be ready for the World Cup and anticipate what's going to happen during the next big games in the future. Last thing I want to mention is the two tools I quickly talk about, which are Amazon Athena and QuickSight. It's like kind of a bonus because it can give like really cool insights and information for the teams. For example, if a team make an API that is it's deprecated now, they will be able to have all the information of the logs and see if their API is still called or not. So. And those tools, it's not for the load test, but it's a good addition to the data lake of our production logs. Now let's talk about the tools. First tool is Amazon Glue, so this is the ETL, and it's not that easy to get your hands on Glue, especially if you don't have a data background. So it's written in PSpark, And it's not that easy to start because it's not that easy to optimize the code. And if you are just a Java developer, for example, it's not going to be easy to get your hands on. So that's why we decide to hire a new employee with data skills. So with that, we could optimize our Glue job so it can take less time and, of course, less money. So not that easy to start with Glue, but for the step functions, it's the opposite. So this was the first time we tried step functions at Betclic, but the subject was very good for step functions because we need to process a lot of different actions in a specific order. So with step function, you can literally go into the AWS console and start playing with it. So with the UI, you can start drag and drop your different steps, and it's very easy to start and kind of fun. And the cool thing is that there are a lot of tools already embedded into the step functions. For example, triggering a lambda, getting data on an S3, copying data into S3. All of those stuff, it's already embedded into the step functions. One other cool thing is it gives you infra as code as well, so you can implement infra as code into your project using serverless, for example. It's going to create your step functions, and it's already there in the AWS console. So let me show you how it looks. So this is two processes of step functions. As you can see, it's a diagram with steps processed one after another. On the left side, you will see when it's good, when it's successful, it's all green. And on the right, you can see that there is an error. But step functions are kind of cool because you can troubleshoot easily. Let me show you. For every of your steps, you will have an input and an output. So for every step, you will have information of what did you give to this step, and it makes troubleshooting easy because it might be because you gave the wrong data to the step function. So very easy to troubleshoot. There are other cool features like catchers to catch your errors and do action according to the errors. So it was pretty fun to play with step function, and it works really well in our case. Last thing, I already mentioned QuickStack and Athena. Just a quick thing on Athena. At first, we use Athena to create our feeder file because we could process like a big query containing all the information we needed to create the feeder file. But with more and more logs to process, Athena was not good, and we needed to go with ETL solution with Glue. But still, we use those tools to share information to the teams and make our data lake available if a team needs to dig down into the API calls we just captured with the user sessions. All right, last thing. Let's talk about how many data we process during an extract. So for 1 day of log extract, we will have 100 gigabytes of raw data. When we go through the clean job, we have 40 gigabytes of data. So as you can see, the clean job is very important to remove all the properties, so we have less and less data. The less data we have, the less the price is, and the process will be faster through the next feeder creation. So once we got our processed data, it's going to be 35 gigabytes, and then we're going to process those data into Glue and the step functions. And overall, this is not expensive at all. It depends on how many events you want to capture, how many data, the length of the time range you choose. All right, I think that's it. I will do some advertising. We got a blog at Betclic where we are writing some cool articles about technical stuff. We got a lot of AWS stuff, for example, so I invite you to go there and read some articles. And I think that's it for us, and we got a bit of time for questions, so don't hesitate. Thank you very much. Come on, questions.
I think it was pretty clear. So, okay, if you have any question after that, we are here if you want. So, thank you.
Yes, thank you. I will just mention one thing. Just try step functions. We had a lot of fun doing this. It's not like a very popular AWS service, so let's try it. You will have fun. Thank you very much.
Thank you.